Friends, I think it's time for us to stop back on science again. It's been quite a while since we did. I'd like to talk a little bit more clearly about Einstein's general relativity. Now, amazingly, Einstein actually started all of the current cosmic physics activities as well as the miniature activities. He came up with the idea of quanta in dealing with light, and then disagreed with the movement of the quantum people towards probability instead of exact numbers. But what I want to talk about again today is general relativity. We remember that he starts out with the idea of fields, an idea that he got from the 19th century great physicist who didn't know mathematics, Fleming, who said electronic fields exist around a magnet and account for the attraction between the parts, not just a slamming together. And in order to illustrate that, he laid a paper on top of a magnet and scattered iron filings on it, and they in fact arranged themselves in a kind of field. But that field goes off into space. It's three-dimensional. And Einstein too said you had fields of space-time, a field between and among objects. And then the one additional thing that I want us to think about is the way in which an object distorts the field around it. And as an illustration, Einstein said it's as if you put a bowling ball on your bed. It makes the bed take a shape around it, except that up in space there's no up and there's no down. So that shaping of space around the object is in fact universally so, and whatever is moving into a distorted area when it approaches those distorted realms around the various physical objects with which it's dealing. That's enough for today. I'd actually like to go down a little bit of a mathematical level with that, but let's let that rest. Good enough for us to have that sense of this giant who developed the concepts that all realms of physics are now dealing with, including miniatures, which he developed using light. Thank you so much for being with me.